Hi, I am Varun Joshi and welcome to day 48 of our Certified Kubernetes Administrator 2025 course. In this session, we are diving deep into how DNS works inside Kubernetes. We will break down the structure of internal service and pod DNS names, understand how core DNS resolves them, and look at what really happens under the hood when a pod performs a DNS query. Whether you are troubleshooting failed lookups or curious how core DNS ties into Kubernetes service discovery, this lecture will give you clear and practical understanding. So, without any delay, let's get started. Now, before I start this lecture, I want to go to the GitHub repository, and there are certain prerequisites for this lecture. First is I want all of you to understand the fundamentals of DNS, and there is a lecture in the channel which will help you develop that understanding. Secondly, we will be discussing the nomenclature of the pods that are fronted by a headless service. So in that scenario, it would be helpful if you understand how stateful sets work and how they are configured in Kubernetes cluster. So I would highly recommend you to watch these two lectures before starting this one. And if you have, let's get started. DNS in Kubernetes. Core DNS is the default DNS server in Kubernetes. What is a DNS server? A DNS server is a server that is responsible for translating your names into IP addresses, names that we humans understand, and IP addresses that machines understand. Now, it runs as a deployment in the kube system namespace. It is exposed via a cluster IP service named KubeDNS. So if I go to my terminal here and I run kubectl get svc and write -n kube system here, then I can see that there is a service with the name KubeDNS created. The service type is cluster IP, and this is the IP of that service, and this service is listening on three ports. It's UDP and TCP port 53, and there is port 9153. These three are also the ports on which your pods are listening, as in the core DNS application is listening. 53 is the DNS port, both UDP and TCP, and 9153 is the TCP port, and 9153 exposes Prometheus compatible metrics for core DNS's performance and health. So if I run kubectl get deploy for kube system namespace, then I would see that there is a deployment with the name core DNS, and this deployment has two pods and both of them are in ready state right now. And if I further dissect our service, if I run kubectl describe svc -n kube system namespace, then what I see is there are two endpoints, and these two endpoints are the pod IPs of the core DNS deployment. So if I run kubectl get pods -n kube system and then I write -o wide here, then you see the IPs of core DNS pods are 0.3 and 0.4, and these are the endpoints on which this cluster IP will be load distributing the traffic. And you can also see that these pods are listening on three ports. Hence, we have configured the cluster IP that way. By we, I mean the Kubernetes cluster. So if you see, there are three ports, port 53, both TCP and UDP, and then port 9153. Now let's go back to our diagrams, and here what you see, core DNS is both modular and extensible, because each function such as DNS resolution, forwarding, caching, or metrics is handled by separate plugins. And when we see the configuration file for CoreDNS, we will see why we are calling this modular and extensible. The last point is it automatically create records for services and optionally pods. So whenever you create a service, a record for that is automatically created, but you can also enable the record creation for your pods, and we will see how you can do it. So if I scroll down, the next section I want to discuss is FQDNs, fully qualified domain names in Kubernetes. And we'll discuss these for services, pods, and stateful sets. Firstly, this is the FQDN format is the syntax. You should remember this syntax because you will be using this day in and day out. Service, for service, you have your service name first, then you specify the namespace, then SVC, then cluster.local. So cluster.local will always be there whether the record is created for a service or a pod. Then here is an example. If I create a service named Nginx SVC, you see Nginx SVC is here, and that service is created in default namespace, which is why you see a default here, .svc.cluster.local. When I talk about pods, now understand that this name will only appear in the DNS table when you have enabled the plugin that will enable pod DNS names. As you can see here, this is optional, and most of the clusters do not enable this, especially in production, because that is a security risk. And we will see why it is a security risk as we move on with this lecture. At the very last, you see a stateful set pod, and all of you understand from the stateful set lecture that whenever there is a stateful set that is fronted by a headless service, all the pods that are part of that stateful set will receive stable network identities. And what you see here is pod 0. Why this is pod 0? This is pod 0 because the stateful set that this pod would be part of would be named pod, which is why you see pod 0 here. Then you see headless SVC, because this is how I named my headless service. If I would have named my headless service potato, then you would see potato here. Then default is the namespace, .svc is given, .cluster.local is also given. And if this particular example, the stateful set only has one pod, which is why you only see pod 0. If your stateful set had multiple pods, like let's say 3 pods, then you would see a similar entry for pod 1 and pod 2 as well. As we understand, in stateful sets, the pod naming is based on the ordinal index. For more information, go and watch the stateful set lecture. I hope you now understand what is the syntax in which FQDNs for services and pods are designed. The takeaway from this is for services, DNS names are always created by default, but when I talk about pods, you have to explicitly enable them. And when I talk about headless service, the pods that are behind headless service, they always also receive stable network identities. And this makes sense because when I am talking about pods, just pods, we know that pods are ephemeral in nature. And we also understand that whenever one application wants to speak to another application, or one microservice wants to speak to another microservice, the communication must be glued using a cluster IP service. When I'm talking about intra-cluster communication, this is because we want proper load distribution, which the cluster IP service can do in an expert way. Now, Kubernetes DNS breakdown. Firstly, before I start this section, I want you to know that when I talk about DNS in Kubernetes, this is internal to Kubernetes.svc.cluster.local. No one from outside can access this service using this name, and the same implies for these two. So the Kubernetes DNS is not equal to the public DNS structure. If you understand the hierarchy in public DNS, then in that scenario, the hierarchy for this name would be dot, we understand that is very at the very last is the root, then dot local would become the top level domain like .com, .org, then cluster will become the second level domain. So if I talk about google.com, then Google is the second level domain and .com is the top level domain. So let's come back here. If I follow the public DNS hierarchy, dot represents the root, dot local represents the TLD, cluster represents the second level domain, SVC represents subdomain 1, default represents subdomain 2, and nginx svc represents the host name. But this is not what Kubernetes adheres to. What Kubernetes adheres to is this one. Now let me scroll to the left so that you can see the entire screen. Let me also shrink this a little because my face might be blocking your view, and then I will quickly scroll this a little up. Now see, while Kubernetes DNS is inspired by traditional DNS principles, and at the core we know DNS is just translating our names into IP addresses, but Kubernetes DNS does not follow the exact structure of public DNS system, and it makes sense because it is internal to the Kubernetes cluster. In Kubernetes, the DNS hierarchy starts with cluster.local, and cluster.local is effectively root for the cluster's internal DNS. So let me summarize what is going on in this diagram. So all services and pods that exist in your cluster, they are grouped under cluster domain root, which is cluster.local. So everything is grouped under cluster.local. Now let's further segregate this. So within this root, resources are grouped by their type. Now what are the types of resources? We know the DNS names exists for pods and services. So the resource types are service and pods, and service and pods can be thought of as subdomains. Now all the services are grouped in the subdomain service, and all the pods are grouped in the subdomain pods. As simple as that. The namespace subdomain acts as further bifurcation to logically organize resources. For example, all services in the default namespace are part of the default.svc.cluster.local subdomain. Similarly, for all pods in the default namespace, they fall under subdomain named default.pod.cluster.local. Now, the official documentation refers to cluster.local as the cluster domain and describe it as the root of internal DNS. So I want you to understand this grouping properly. So cluster.local is the one under which everything resides, like service and pods. Then there are two subdomains, one for service and one for pods. and then there are further subdivisions by the namespace domain. So if that is the reason the nomenclature is like this. So if you want to reach an nginx service that resides in the default namespace, then you reach out to nginx svc.default.svc.cluster.local. Once you understand this, it becomes really simple. I want to highlight one more thing right now. Whenever you enable DNS names for your pods, what happens is they get naming based on their IP address. So for example, if there is a pod whose IP is 10.244.44.55, the DNS name for that pod becomes 10-244-44-55. But again, I want to stress on the point that pod only receives DNS names when you enable them. By default, they don't, and I have not seen a project which requires pods to have DNS names. Pods always sit behind a service, and you reach that service which will automatically distribute the load between the pods. Again, headless service is an exception. The pods sitting behind your headless service and part of StatefulSets will receive stable network identities. This distinction is important to understand. So we have seen here the pods that are part of headless service will receive stable network identities, and their entry will be there in the DNS table. So the first is service, the third is stateful set. Pods do not receive stable identities until and unless you explicitly enable a plugin, and we'll see that plugin as we move on with this lecture. Now the last thing I want to show you is how a typical DNS table that is maintained by CoreDNS will look like. So for example, if you have created an nginx service in the default namespace, then there will be an A record created for it, which will map the IP address for that service. So for example, here this nginx service has this IP address. So whenever a pod wants to reach this nginx service, then CoreDNS will perform the translation and the resultant IP would be this one. And similarly, if there is app1 service in app1 namespace, when you try to reach it, the CoreDNS will be consulted and it will translate this name to the IP address of that service. And similarly, if you have enabled DNS names for pods, then if someone tries to reach this, then the IP would be translated to this one. And we will see all of these things in our demo section. And similarly, I have also mentioned the entry for StatefulSet pod. If this is your pod's name, then this IP would be the IP of this pod. And then headless service, we all know there is the cluster IP for a headless service is set to none. Hence, there is no cluster IP that you see here. I hope all your dots pertaining to how the naming is done, how DNS resolution works are clear. But if there are still any doubts as we go on to this demo section, most of those doubts will be cleared. Now let's do one thing. Let's go to the terminal and see the DNS configuration inside the pod. So I will go to my terminal. I will clear my screen here, and I want you to notice the IP of the cluster IP service here. You see the IP of the cluster IP service, which is for KubeDNS, is 1096.0.10. Just remember this IP address. Now let's create a debug pod first. I will write kubectl run debug pod, and I want an interactive terminal. The image I want to use is Nikolaka NetShoot. -rm, then finally I will write I want a bash. Now what this command will do is it will create a debug pod for me. -rm ensures that once I exit that pod is deleted and the shell I want is born again shell. Now this image that I am using is an important image. Whether you are doing network troubleshooting, you are trying to implement network policies, or you are trying to curl something, this image has most of the tools installed like dig, ns lookup, curl, ping, telnet, tcp dump, and a lot many tools. So this is an important image. I'll press enter and my pod is ready. I will paste something here which will make my prompt colorful so that you can easily distinguish where we are on the screen. Now I will run ns lookup debug pod. You see, server can't find debug pod. So one thing is clear, there is no entry with the name debug pod. Now what I told you, when a certain plugin is enabled, the pod will get DNS names automatically, and those names are separated by hyphens. Now I can run here ipadd to know the IP address of this pod, and here is the IP address of this pod. So I will quickly copy this, I will paste this here, and then I will add hyphens here instead of dots, and then we have created this in the default namespace. So I will write default dot pod dot cluster.local, and I am typing what we just learned. So if I go back to my diagrams, you see whenever you have a pod and you have enabled that DNS names plugin, your pod will receive an IP address. Then you type the namespace name .pod.cluster.local. That is what I have done here. And now what I will add here is ns lookup. And when I press enter, you see, if I am trying to ns lookup this name, I am getting the IP of this pod. But when I tried to ns lookup a debug pod, which was the name of this pod, then it was not able to resolve it. Now we understand that by default, this plugin in kind is enabled, which is why my pod received a DNS name. Now, why it is enabled by default in kind is because kind is predominantly used in local environments for development and testing. Hence, the developers of kind decided that we should enable this setting. Now, enabling this is not rocket science, as we will see as we progress with this lecture. Now, you can also ns lookup something like kubernetes.io, and if you do that, you receive the IP addresses of Kubernetes. I will clear my screen. Now what I want to do is I want to create a deployment and a service for Nginx. So I will move to this terminal. I will zoom in here and then I will clear my screen and I will write kubectl create deployment, and I want to name this deployment nginx deploy. We are using imperative commands here. Image is nginx, and this will create a deployment named nginx deploy. I'll press enter. This will only create one replica, and one replica is what we want for our testing. Now let's expose this deployment. I will write kubectl expose deployment. The name of my deployment is nginx deploy, and the name of the service that will be exposing this deployment will be nginx svc, and the cluster IP port would be 80, and I'll press enter, and this says the deployment is exposed. I want you to understand one thing very clearly. As soon as I create this nginx service, a DNS entry is made in the CoreDNS pod, which now knows what is the IP address of this nginx service. So if I run kubectl describe svc, nginx svc, you can see that this cluster IP service has received this IP address 125.193. Now let's go back to our debug pod. Now I will run ns lookup nginx svc. I am just writing nginx svc. I am not providing the FQDN here, and I will now press enter. And voila, 125.193 was the IP address, our cluster IP service. So ns lookup is working. Critical point to note, both service and this debug pod are in the same namespace. And similarly, I can also curl nginx service and it will show me the nginx default page, which is expected. I hope till now everything is understood. Now I will cat an important file in the pod. This file governs how DNS queries are handled in your pod. So I will write cat etc resolve.conf, and these two lines I want you to concentrate on. So let's see what is happening in the first line first. Whenever I write nginx svc, first this will be auto suffixed, and when nginx-svc was suffixed with this, then that became the FQDN. Again, if I would have typed ns lookup nginx svc dot default, then suffixing this would not have helped. But there are multiple search targets 1, 2 and 3, then it would have appended this one. If we append this, then again this becomes the FQDN. If I would have typed .svc as well, then this would not work, this would not work. Finally, it would add cluster.local, and then it will be able to resolve this. So if I just press enter, then also it is able to give me the address because of this search tab here. Secondly, I have a name server tab, and name server tab is the one which specifies who is the DNS server for you, dear pod. And we know what is the cluster IP services IP address. It is 1096.0.10. So if I write here kubectl describe svc-n kube system, and I check this for KubeDNS and I press enter, you see 1096.0.10 is the IP address of my cluster IP service named KubeDNS. You see that IP is mentioned here. This is the reason your pod can seamlessly reach out to the DNS pod for resolving your names to IP addresses. Now let's do one more thing. Let's ping kubernetes.io. Aha! Kubernetes.io is sitting behind AWS's global accelerator. So let's press Ctrl C, and this is the IP address that is responding to us. There is one more file I want you to understand, and that file is called etc hosts. So let's do one thing. I will vim into that file, vim etc hosts. Now this is the file where static entries can be stored. So if I want kubernetes.io, whenever I ping kubernetes.io, then it should ping a different IP address. I can do that in this file. So I will go here, I will go into insert mode, and then let's do one thing. I will check the IP address of my nginx pod, kubectl get pods -o wide, and I press enter. You see the IP address of my nginx pod is this one. I'll copy this IP address. I will go here, and then I will paste that IP address here, and I will write kubernetes.io. Now what I am telling my DNS configuration is, my DNS configuration will look at etc hosts file first. If that entry is not available here, only then it goes to my name server. Okay, so I will save this file, and when I do this and I ping kubernetes.io again, then the response is given from my nginx pod, not from actual kubernetes.io's IP address. Now I want you to understand why this is happening. This is happening because of hierarchy, because of priority. By default, it is always the etc host file that is looked, and after that the name server is queried, and you have the opportunity or the authority to change this behavior. And what you can do is you can cat into a file called etc ns switch, I think. Yes, I have to spell it right, nsswitch.conf. And if I press enter, you see in the host section it says first check the files and then DNS. So if you bring DNS first, then it will always check with the name server first. So I just wanted you to know this. One more point. So if I write ns lookup kubernetes.io and then press enter, this gave me the original IP addresses. This is because whenever you are using utilities like nslookup or dig, they will directly query your name server. So remember this distinction. No one is asking you these questions, but when you are doing troubleshooting, these things always help. And if I add dig, dig also will return the actual IP addresses of kubernetes.io. Now let me clear my screen. Let's see cross namespace behavior. Now I will go to my second terminal again. I'll clear my screen. I will run kubectl create deploy. Now I will create a deployment in a different namespace. So first let me create that namespace, kubectl create namespace app1ns, and then I will say kubectl create deploy in -n app1ns, and this one I want to use the nginx image, and I will press enter. I have to add the name of the deployment. Let's name it app1-deploy. I'll press enter. It says created. Now let's expose this, kubectl expose deployment, and the deployment that I want to expose is part of app1 namespace. The name of that deployment is app1 deploy, and the port on which I want to expose this deployment is port 80. And I think we are good. I have provided the name of the deployment, but I have not provided the name of the service. Let's call this app1 svc. I'll press enter and it says exposed. If I run kubectl get all -n app1ns, then I see there is a service created for me which has IP 10486, and then there is also a deployment created. If I run kubectl describe svc -n app1ns and the name of the service is app1 svc, you see there is one endpoint, and that one endpoint will be the pod that is part of our deployment. Now let's go back to this terminal here. The service that we have created is named app1 svc. Again, I want to highlight this point. As soon as I created this service, a DNS entry was automatically created for this service's DNS name. Now let's go back to the debug pod again. I want you to understand that the debug pod is in the default namespace and app1 svc resides in app1 namespace. Now I want you to see one interesting thing. If I cat etc resolve.conf here, I want to go inside this pod. I will write kubectl exec -it, and it is -n app1ns, and there is only one pod there, app1 this one, and then I want a born again shell here. If I go here, I cat for etc resolve, then I want you to concentrate on one thing. The search targets have changed based on the namespace in which the pod was created. This is extremely important. Now I want you to understand that the search target in my debug pods are part of the default namespace. If I run here ns lookup app1 svc, this will not work because automatically what is being appended is this, but there is no app1 svc in the default namespace, hence this will not work. But as soon as I add .app1 ns here, this will work. And why this worked? Now you see the IP address of app1 svc. This worked because once I added this here, once I added .app1 namespace here, it auto suffixed this thing. And once this thing was auto suffixed, this is the DNS entry that is available in my DNS pod, and my debug pod is configured to query the cluster IP service that is fronting my DNS pods, and hence the name to IP resolution was performed successfully. Keep these things in mind. Whenever you are doing a cross namespace access, you will have to supply the namespace name as well along with the service. I hope all the dots are connected. Now I want to connect more dots. So let's talk about the DNS pod itself, how it works, where is the configuration file for that DNS pod. Now let's go to this screen. I will exit from here. I will clear my screen. I will run a command kubectl get deploy -n kube system, and this will show me the core DNS deployment. Now let's run a describe on this deployment, kubectl describe deployment -n kube system. And what I want to see is, I want to see the core DNS deployment. I have to spell system right, and then I can press tab for auto completion. I'll press enter, and this is my deployment file. I want you to concentrate on this thing, etc CoreDNS Corefile. So the configuration file is named Corefile, and that configuration is mounted onto this path. One is this, but from where is Corefile coming from, Varun? Now I will scroll further, and here are the volumes that are mounted onto this DNS pods, or all the pods that will be part of this deployment. And the volume type is ConfigMap. So you are mapping a ConfigMap as volume. Any confusions? We have covered ConfigMaps in greater depth in one of the lectures. I will link this. Do watch if you do not have good understanding of ConfigMaps, because ConfigMaps are extremely critical, because there is no production implementation that does not use a config map. Now let's come back here. Type is ConfigMap, name is CoreDNS, and if I scroll here, here are the mounts. You mount this into etc CoreDNS. So what I now want to look at is the contents of this config map, and the name of that config map is CoreDNS. If I get to know what all contents are there in this config map, I would know how a configuration file looks like. Correct? So if I run kubectl get pods -n kube system, and not get pods, get cm, and I press enter, you see I have to spell this right, and you see here is the config map named CoreDNS. Now let's do one thing. Let's run a describe on this config map. I will write describe here, And then let's also supply the name of the config map, which is CoreDNS. I'll press enter. And if I scroll up, the key is this and the value for this is this. So what you will see there is, if you go to this location, there will be a file with the name Corefile created. And why this will be named Corefile? Because the key of the config map is called Corefile, and then the value of this is this. Now let's dissect this file. I want you to know that the description of this file is there in the GitHub notes as well. If you want to refer them, be sure to do that. First is errors, logs DNS errors for easier troubleshooting. Then there is health, exposes a health checkpoint, and there is 5 seconds, lame duck 5 seconds. So, and wait 5 seconds before shutdown to allow connection draining. So if there is a shutdown, you give 5 seconds of time so that the in-flight connections can be completed. Then what you see is ready. This adds a readiness probe endpoint, so Kubernetes know when CoreDNS is ready to serve traffic. Then what you see here is handles DNS for Kubernetes service names and supports reverse lookups for IPv4 and IPv6. What are reverse lookups? Reverse lookups are IP to name resolution. So DNS normal is DNS lookups are name to IP translations, and reverse DNS is IP to DNS names translation. Pods insecure. Firstly, what is pod insecure? Allows pod IP based host names, we know with hyphens, to be resolved without verifying if the IP actually belongs to a running pod, which may result in stale or spoofed DNS entries. This is the reason this plugin is not used in production. But Varun, why is that? See, when the DNS records for service names are created, API server is dealt with. You inform the API server, and API server is the one which handles the transactions, and hence you have TLS and everything in place. But when you talk about pods, API server is not involved in the DNS creation for pods. Hence it is insecure because it does not adhere to TLS, which is why it is clearly said the IP addresses are not verified, which may lead to stale or spoofed DNS entries. Then there is Prometheus 9153. We already understand that DNS pod exposes port 9153, which can be polled if you want to see the health statistics. Then you see here cache 30, disable success cluster local, disable denial cluster local. This says that for external entries, like if you are pinging google.com or kubernetes.io, then you cache those entries. But when it comes to anything that is part of cluster.local and all your pods and all your services, including headless service pods, they all are part of this one, because this is the root of the cluster. We discussed this initially. What we are saying is, for external things, you cache the entries, but disable caching for anything that happens within this zone, because we know things are dynamic, things could change. Hence the caching is completely disabled for anything part of this zone. Then there is loop, detects and prevents infinite DNS query loops caused by misconfigurations. Reload automatically reloads core DNS whenever you make any change to the core file, that is the configuration file of core DNS. Load balance implies randomizes DNS responses to evenly distribute load across endpoints. I want you to know one thing. This file is separated from the DNS pods, and there is a reason for that. If I want to modify something, I will just modify this core file and the changes will be applicable. And I already have this reload flag which will allow the configuration, the pods to reload whenever I make a change in this file, which is why the theme of our lectures, this is the reason they have decoupled the configuration file and given the access to you and me so that we can make changes based on our requirements. Now, this is all I wanted to discuss, but there is one more section I want to cover, which is called troubleshooting. Now, in exam, you could face a scenario where DNS pod is not reachable or the entries are not working properly. So I want you to know the basic troubleshooting that you can perform in the exam or in real life whenever you are stuck. So for that, I will directly go to the GitHub repository. We have covered all these commands, but I want to specifically mention them so that you keep these things in mind. So if I go to DNS troubleshooting in Kubernetes, then firstly, verify CoreDNS is running, and you know how to verify that. Run kubectl get pods, all the pods should have ready status. Then check CoreDNS logs. It is very simple. You just write kubectl logs and the pod name. We have already done this multiple times throughout this course. Test DNS within pod. You know how to do it. Run a test pod and perform this basic testing, whether everything is working as expected or not. Verify resolve.conf. If a pod is facing the problem, then verify it has these entries. These entries should be there. If search is not available, then if you ping nginx -svc, it will not work. So if I go to my terminal and let's go here, if I edit this file etc resolve.conf and I just delete this entry altogether and I save this file, and if I now do ns lookup app1 svc dot app1 dot ns, then it will not work because the search targets are removed and this does not understand what is this. But if I enter the full name here, app1 ns, and then this is a service, then I will write cluster.local and this will work because now I have provided the FQDN. But if the search targets are not there, then providing half-baked information will result in errors. So keep these things in mind. So now let's go back to the GitHub repository. Then now check NS switch configuration. Maybe your pod is looking at the files first and the file has a malicious entry. So keep these things in mind. Then finally, you can also inspect the core DNS configuration and you can refer these notes where I have detailed what all these blocks are doing in the DNS configuration file. Inspect core DNS ConfigMap. We just saw this. Check for network policy or firewall rules. Any confusion, go watch the network policies lecture. We have covered real-time scenarios there. Validate kubelets DNS configuration. Look for loop or forwarding errors. Now, I want to mention one more thing. We checked the configuration file, but I think I forgot to mention one thing. Oh, we're checking it in this tab, right? Yeah. If you look here it is saying forward to this. Now, what is this? So your pod is looking at this file to figure out which is the name server that it must consult. But if that name server does not have answer, if the DNS pod does not know what is kubernetes.io, then where should that request be forwarded? By default, these requests are forwarded to your worker nodes etc resolve.conf file, whatever name server your worker nodes have or your control plane nodes have. So keep this tab also in mind. So if this is not there, then you might not be able to reach out to external systems. I think that is all I wanted to cover in this lecture. That wraps up day 48. You now know how Kubernetes DNS works, how core DNS is configured, and how to interpret internal FQDNs. In the next section, we move beyond the cluster to explore how external traffic reaches your apps with Kubernetes Ingress. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.